their extremities or toes, fingers, and hands. They were mostly just for cosmetic reasoning. In the Renaissance, they started to put pulleys and strings to assist in a particular movement. It did not really move, they were just meant for one particular action, such as for knights, they would tend to just be able to hold the shield up, or for more wealthy people to hold just so that it's not missing. In the pre-modern era, improvements in multifunctional devices and procedures started developing, so we had better surgery, which meant that instead of a hole and having it cut off, we would only remove a certain area that was damaged. Post-World War II, more funding was put into research to include electrical devices onto the prosthesis. For us, the golden standard would be a fully functional arm, which would include bones, joints, muscles, nerves, vasculature, and a protective layer. So a functional arm, we want an arm to do all the basic things that the real functional arm does, such as enable hand motions and functions, able to reach objects which are further distance away from our bodies, and to help us with our balance. The properties that need to be recreated would be that of motion, strength, ability to hold objects. Of course, the material that we're using needs to be biocompatible, and it needs to be durable because we don't want to keep replacing the components repeatedly. So some of the candidates or the motivation behind why we want to do this is because people tend to lose limbs either in traumatic accidents such as car accidents, or when they're operating machinery, or veterans that come back from wars missing limbs, and we want to be able to help them. Also, we have people born with anomalies or deficiencies. Some of these be blood diseases, which don't allow proper circulation to the limb, and thus it needs to be removed, or you can just not be born with a functional limb. There are also diseases which may cause a person to lose a limb, such as cancer or diabetes, so we have to.
Okay, so there are currently 3 types of prosthetics out on the market today. The first is being purely cosmetic, and it's just so it doesn't look like there's something missing. And it doesn't move, you have to position it the way you would want it. The next step up is the body powered, which requires you wearing a heavy harness and it's cable powered, but your other hand has to enable the movement. And the one we're going to be focusing on is the myoelectric arm, which is actually hooked up to your nerves, and there are a lot of electrical components and motors, etc. So how it works, the basis for a myoelectric arm is electromyography, which originates from the repolarization and depolarization of your nerves, which we learned about in this class. And as the signal travels down from your brain to your body, we can use surface electrodes that pick up that signal, convert it into an electrical signal, which can then be sent to the arm, which can tell it to do whatever function you were originally thinking. It's important to note that while this arm is stimulated by your body, it's not powered by your body, it is battery powered, which needs to be replaced. So this is a diagram showing the overall process for a person who would undergo this procedure. The first step would, doctors would go in and surgically redirect nerves that were originally in your arm to your chest. And that way when the patient thinks, move my arm up or whatever they want to do, the nerve then sends that signal that I talked about earlier down to the arm. It's then converted into an electrical signal by the computer, and then the arm does whichever the person was thinking originally.
So because of the high cost of the myoelectric arm, most insurance companies have strict policies when it comes to who gets to receive one of these devices. They usually have to meet a set of requirements, which include missing limb at or above the wrist. They have to be able to prove to some degree that the body-powered device is not sufficient enough to meet a standard daily living. The remaining musculature must be able to stimulate the device so that you can actually use it. And the patient has to pass the test basically in front of doctors, and basically they have to be certified. The range of voltage that the musculature must be able to provide is between 5 and 20 microvolts, and so if you can't stimulate the myoelectric arm, you're probably going to be fitted with either a body-powered one or a cosmetic arm. As far as a child, if a child is to receive a prosthetic, if they're below the age of 1, they'll receive a cosmetic one until they're over 1, and then after that, they can either get a myoelectric or a body-powered one, but usually they have to be refitted every couple of years as they grow. The advantages of a myoelectric arm include that they're more cosmetic, they're not quite as bulky, or they don't have cables attached to them, they're less involved. They extend the range of motion of your arm, even to the point when they exceed that of a normal human. They've shown some myoelectric arms to fully rotate their shoulder socket all the way around, so that could be seen as a bonus. It doesn't require the use of a harness or your other hand, such as in the body-powered or cosmetic, where you actually have to position your prosthesis yourself. It has an improved grip force. This includes having a strong grasp while including delicate handling, and it allows a sequential operation of your different joints. Some disadvantages include that it's not recommended for heavy work because if you damage it, it is expensive to replace. It requires more care and maintenance than a body-powered or cosmetic. Usually you have to replace parts every 5 years or so as they wear out over time, especially if you have heavy use of it. It is a one-way system as of now. You can send signals from your brain to your muscle cells to the prosthesis, but you're not going to be able to have any sense of touch in the arm. And there are heavy parts involved in this function. As far as future work, we hope to incorporate organic and inorganic materials together and lower costs, and hopefully get overall increased range of motion and mobility. Either.
Okay, questions for them?
How long would it take to get approved of a myoelectric arm?
As a patient?
As a patient, yes.
I think it goes through your insurance company mostly. You send an application and they check you out. Send you, yeah. Basically, you just have to meet the requirements.
And does doctors determine that, or do you have to talk to someone specifically?
I think the doctor can recommend you, but you have to go through your insurance to get the ultimate say. I mean, unless you want to pay for it yourself. I guess you could just say, give me one, and I'll just put the bill, but generally that doesn't happen.
No other questions? Okay. Oh, is there one more? Where?
So as far as controlling, you said that it was connected to the nerves.
Yeah, it puts you up to electrodes which are attached to your muscle cells. One problem with that they found is as you move your muscles, the electrodes can change distance between the two, and so the microvolt difference across can change, which has posed a problem. So one future work that they hope to look into is having your electrodes move based on how you want your arm to move. So hopefully you can do that. Or equivalent, I guess.
Do you ever have to worry about overheating when it comes to using the myoelectric arm?
I didn't see anything about it, no. I'm honestly not sure, but I didn't see anything on disadvantages or anything, so. Not that I know of.
They didn't mention anything about the overheating of the buttons of it.
We looked at some reviews of people who have this, and most of their complaints were that it was heavy, not that they had problems with overheating.
Anything else? Okay.
Well, I have a question actually.
Oh,
You guys
Yeah.
mentioned that this device was not body powered and it required some kind of battery. How long do you think this battery would last, with typical use before you had to get a replacement?
It usually comes with a charger and you plug it in. I think they said you replace the batteries every couple of years.
Do you happen to know how long the charger would last for?
I have no idea. I didn't know anything of that. I'm sorry.
That's fine. I just was curious.
Yeah.
okay.